Three, two, one. Over recording. Hi, my name is Mark Cooley. I'm a sophomore at Mount San Antonio College. I am also 9 hours ahead on a cruise ship, so hopefully the wind isn't too loud. Let's get into it. My presentation is going to be on timeology. So, timeology, the term made by me, is super similar to the term horology. I just realized my slideshow's in there. Horology, which is the study of time slash making of clocks. So, what is time? I was kind of, I kind of came up with this question back when I used to watch Spider-Man Into the Spider-Verse, where Miles goes into a classroom late, and when he was asked about why he's late, he mentioned that Einstein said that time was relative, and it kind of got me thinking, like, what does he mean by that? Why would he say something like that? So the dictionary definition of time is the measured or measurable period during which an action, process, or condition exists or continues. So pretty standard. Go to any dictionary, that's kind of what it says, encyclopedia, blah, blah, blah. But the true definition is really unknown. I mean, you look up what is time, and there's many articles going into that time is illusion, time is man-made, time is this, time is that. And like this definition only appears officially, but a lot more other people are kind of not on the same page. And I guess we're going to go into that today. So, how is time measured? Well, back in the day, about like 3,000 years ago, the Egyptians came up with sundials. So basically, shadows from like a pillar in the middle that kind of cast it down and kind of told these like ancient people like what the time was. And this is pretty universal at the time. Um, After that came like hourglasses, water clocks, candle clocks, and then the first mechanical clocks came out in Britain, in 1510. So pretty basic stuff. Then over time they developed into analog clocks, digital clocks, watches, which is like a small analog clock, iPhones, which is like a mobile digital clock, and iPhones nowadays go off of the atomic clocks. These are the most accurate clocks that we have. They use atoms that basically tick. That's our time. So what does that mean? Is time man-made? Well, short answer, yes. See, this quote by Einstein, basically this very well-known physician and just scientist, the most influential in our history, basically says that time is an illusion. I mean, what can you really say from that? Is time really an illusion? A great podcast by NPR. When I found it, I was actually like astonished. They go into a lot of different concepts, but basically, atomic clocks are ran by our governments, and that time is basically government mandated. They basically give up the idea that the clocks that the atomic clocks, or the time that the atomic clocks give us, isn't what our government tells us the time is. And I think that's a very interesting idea. Time being a social construct creates efficiency and productivity in society. And this is kind of like a known fact. Like I'd say, like at my job, when I know I'm running out of time, I'm definitely going to work a little bit harder just to meet that deadline. Governments like this, so they like to give us the time. And talking about time, general relativity and space-time come into mind. See, I'm not going to get too much into general relativity. It's a pretty complicated subject, but this definitely affects our time. If you really, our atomic clocks, so our iPhones, right? They get the time anywhere in the world via satellite. But atomic clocks on the seafloor or on the sea level are a little bit tick a little bit slower than the ones in our satellites and the GPS. Those tick a little bit faster. So there's just the general relativity of that changes. And gravity has a factor in that space time. Here's a demonstration of the light kind of in space-time. This is kind of how our time works too. And then you also have to think about the psychological passage of time. When you're having a good time or playing video games or just hanging out with friends, like time's gonna go by a lot faster than it would be if it's like a slow day at work. Definitely something to think about. So, what is time? Well, our current definition is that it's man-made, government-mandated, social construct. It's an illusion, and it requires general relativity to exist, technically. So why do we follow it? That was my reaction when I came up with that question. Why do we follow it? I mean, come on now. And it leaves kind of like a hypothesis, like, what if time was the same everywhere? Or what if we got rid of time zones? You know? Real science with real problems of time zones. As you can see here, here's a little bit of a map of all the different time zones, but to be honest, like, if you really look at it, our time, it's not really accurate. And like, if you look here, I'm currently in Sweden. I'm 9 hours ahead of the Pacific Standard Time. I'm currently getting like 15 hours of daylight, which is like a whole lot different than the daylight than the amount of time we're getting back in the States. And time goes by the exact same. I feel like technically time relatively goes slower out here than it does down there. I guess science can kind of explain that a little bit, but what if like relatively time did go slower up here? So the obvious cons of not having time zones might be confusing, hard to mandate, hard to keep track of, and probably more labor, as we would all have to try to figure out the time by ourselves. But the pros, it'd be more accurate depending on the region. There'd be more freedom, so it'd be less government mandated. More practical uses of general relativity, so it would be exactly accurate to that very location. And possible innovations for timekeeping, meaning there might be better ways of timekeeping or even new ways of discovering time. I think it'd be a pretty good thing. Anyway, that's my presentation on Timeology. My name is Mark Foley. Thank you for having this class. Super informative. I actually found out a lot more about science than I don't know